Surface integrity is the silent guardian of quality and performance. After manufacturing, the surface of a material reflects its physical, chemical, and mechanical state, shaping both how it looks and how it lasts. But tiny defects like microcracks, porosity, oxidation layers, and delamination can silently compromise its durability. In biomedical applications, for example, yttria-stabilized zirconia used in dental implants undergoes hydrothermal aging. Over time, exposure to heat and moisture triggers a tetragonal-to-monoclinic phase transformation, leading to microcrack formation and grain pullout. These microstructural changes increase surface roughness, degrade translucency, and weaken mechanical strength, affecting both the appearance and the long-term reliability of dental restorations. Whether in engineering or healthcare, controlling surface integrity is essential to ensure that what looks strong remains strong throughout its lifespan.